You know, in the world of sensor manufacturing, there's this hidden problem that quietly eats away at profits and really limits performance. But what if there was a way to fix it? And I don't mean during production. I mean on the finished devices themselves. A way to unlock millions in value. Let's break down exactly how that's possible.
And we're not talking about small change here. We're talking about unlocking between $10 and $25 million in annual value. And that's for a single product line. So what exactly is this multi-million-dollar problem?
Well, it all comes down to a challenge that pops up really late in the manufacturing game in what's known as the back end of line, or BEOL. This is where one single technical hurdle can have these massive financial consequences, and that hurdle is something called leakage current.
So what is leakage current? Okay, the easiest way to think about it is just electrical noise. It's like static on a radio, this unwanted background signal that has nothing to do with what the sensor is actually trying to measure. And that noise, it just degrades the accuracy and performance of your final product.
And this is right where a technical headache blows up into a major business problem. That electrical noise, it creates this whole ripple effect of costs. It inflates your test and calibration budgets. It forces you to either downgrade or completely scrap devices, which is a direct hit to your yield. And even for the parts that do ship, you're looking at degraded quality and higher power consumption, which really impacts things like battery life.
So, the obvious question is, why not just fix it? Well, this is the core of the dilemma. Let's call it the BOL thermal trap. On one side, the standard fix for this kind of thing needs you to bake the device at crazy high temperatures. We're talking over 350 degrees Celsius. But on the other side, a nearly finished device with all its delicate layers? No way, it just can't handle that heat. It has a super strict thermal budget, often below 250 degrees. So you're trapped. You literally can't apply the cure without killing the patient.
So how do you get out of that trap? This is where a totally new approach comes into play, one that's designed specifically to work inside that tight thermal budget. Let's take a look at the Sisu Semi solution.
The big breakthrough here is a process called atomic level purification, or ALP. And get this, it operates at just 200 degrees Celsius. That temperature, that is the absolute key. It's well inside the safety margin for finished devices, which means you can treat them at a stage where it was just never, ever possible before.
And really, this is the main takeaway. This low-temperature process unlocks performance improvements that were completely off limits. It fundamentally changes the game for what's possible after the main fabrication is already done.
Of course, a claim like that needs some serious proof. So, Sisu Semi went and validated the process using third-party commercial sensor components. Let's dive into the results.
Okay, first result, a 58% reduction in the median leakage current. That is a massive drop in that unwanted electrical noise we were just talking about. But as impressive as that number is, believe it or not, it's only half the story. Because what's arguably even more important is this: a 72% reduction in the variation of leakage across devices. Now, what that means is much tighter uniformity, greater consistency. And for anyone in manufacturing, you know predictability is king. This number is huge.
So what does a 72% reduction actually mean for your day-to-day operations? Well, it means way less time spent on calibration. It means more predictable yields. And ultimately, it means the products you ship are far more consistent, delivering the performance your customers expect every single time.
All right, so we've got the technical improvements down. Now let's connect them back to the money, back to that $25 million opportunity we started with. Where does all that value actually come from?
And this right here is probably the most powerful insight of this whole case study. You might think the main value comes from yield recovery, saving all those devices you'd otherwise have to scrap. And that's valuable for sure. It accounts for about 15 to 20% of the gain. But the overwhelming majority, over 80%, comes from what's called ASP uplift. This means you're not just saving bad devices, you're making your good devices better. So good, in fact, that you can sell them in a higher performance tier for a higher price. It's a total game changer.
And look, these aren't just abstract numbers. The analysis actually breaks down the potential annual gain by sensor type. For CMOS image sensors, the opportunity tops $24 million. But even if you look at optical sensors like LiDAR or RF sensors for IoT or chemical sensors, we are still seeing significant multi-million-dollar opportunities right across the board.
So let's put it all together and just recap the whole story here. We start with that core problem, the BEOL thermal trap. Then comes the solution, that 200-degree ALP process that delivers a huge reduction in both median leakage and variation.
And that all leads to the big financial result, a $10 to $25 million opportunity, driven mostly by turning good products into premium ones.
The data is really compelling, and the financial model is crystal clear. So the final logical question is, how can you find out if this will actually work for your products?
Well, the path to validation is actually designed to be super straightforward and low risk. Step 1 is simple. Just treat a sample of your own sensor components. And because this can be done after dicing, it's a really fast and inexpensive trial. From there, you can quickly generate your own data and quantify the precise impact on your yield, your performance, and ultimately, your bottom line.
If you have any questions, please contact www.sususemi.com.